I want to get to lead screw. Yep. So
Ini Sokratif nggak ada kan, Pak?
oh ya, kita belum Sokratif ya. Mungkin minggu depan aja.
Oke, Pak.
Ini di jam 12 sih. Bagaimana ya? Lead screws. Okay, lead screws are, there are two kinds. Yeah, ada lead screw, ada ball screw. Trying to find, yeah, you see this all over the place, right? Like a screw press. This is actually like a screw. Ini jack buat dongkrak, right? You get the mechanical advantage from rotation to linear, right? Jadi from rotation to linear motion, and then you go up, right? Mechanical advantage. C-clamp is essentially using a power screw method. Vice also here, right? You rotate and then you get translational motion. But here, the point is not to assemble part A to B, right? The point here is to move things, right? The point is to move things. And you have these mechanical power screws. Okay, let me get you to see some lead screw videos. Okay, I'm gonna send you 2 videos. Okay, once you finish watching them, get back to Zoom.
Pak, kalau mau nanya dong, Pak.
Ya.
Ini kalau yang power screw ini bisa nyambung ke itu nggak ya, Pak? Ke twin screw, Pak. Yang twin screw, Pak. Yang kayak supercharger gitu, Pak, tipenya.
Well, twin screw supercharger is a supercharger. It's not a power screw, but the blades, or so-called the compressing blades, are in the shape of a screw. So they use kind of a screw geometry to create the pumping motion. So they just rotate and it pumps axially, right? So that's not a structural mechanical power screw in that sense. Well, the video is kind of long, but I will not discuss ball screw that much, so I just let that video does the job. We will talk more about lead screws. They are a little bit more common in simpler machineries and in lighter duty machineries because they're just cheaper, right? So we will talk more about that. And besides, ball screw calculations, they tend to be more like ball bearings, because you see the dynamic load rating, the static load rating. They're all the same terminologies as in your rolling contact ball bearings, right? Because they essentially are, but it's just the motion is not just full rotation. The motion is linear because of the geometry. Now, let me show you, a typical arrangement for lead screw application, converting rotation to linear motion. And many times you want positioning, right? I mean, these are linear positioning slides. Next week, I'll talk more about linear motion. But for now, I just want you to see a typical arrangement. You have to put this power screw or the lead screw on ball bearings at the end. Yeah, because it is the screw that rotates and then the block moves translationally, right? It's not like you move the block to move the shaft. It's the other way around. Is you move the shaft and then the block translates linearly, right? So moving the block to to rotate the shaft means back driving. Okay, so when in the video it talk about back driving or back drivability, means that can you move the block to rotate the screw? Or in a vertical sense, you know, if you think about in a lifting mechanism, right? Think about this, right? I mean, if you're lifting something like di bengkel ya, kan mobil kamu naik, it's a hydraulic jack. Many times electric, not hydraulic. You actually turn the power screw to lift your car up, right? So in lifting applications, especially, you don't want back drivability, because then you have to keep the torque on in order to keep your car on top, right? You don't want back drivability. You want the load to be, no matter how heavy the load is, you cannot drive the shaft. You have to let the shaft drive the lifting block, right? So that's what it means by back drivability. Right? So if you have lifting applications like this, you don't want back drivability. But what is another scenario that you do want back drivability? Can you mention an application where you do want back drivability? Any ideas?
Kenapa, Pak?
In which application do you want back drivability? Usually,
kemungkinan ada nyangkut, Pak.
Yeah, you usually want back drivability when you're interacting with humans, right? Because the human will drive it back, and you want the motor to untuk ngalah gitu kan ya. Jadi collaborative robots, for example, you want back drivability. Kalau mekanisme itu menggerakkan sesuatu yang kamu mau bisa melawan dengan tangan kamu, misalnya kalau you want to move it manually, then you want back drivability, right? Just a short comparison between lead screw, where it is a friction, no balls, yeah, just a thread. Lead screw cost less. They're usually more they're self-locking, so means, you know, you can move the block and it's not going to move the shaft, not back drivable. So if it's not back drivable, you do not require a braking system. So it's usually better in vertical applications, less efficient, but might be acceptable, right? They have higher friction and run hotter, so not for high speed. Yep. Ball screws, they require braking systems, but they are more efficient, less torque, lower friction. It's cooler temperatures because less friction, right? It needs some grease or oil, but they're a bit noisy. Okay, they're more expensive too. So when you have when your need is quiet, right? Lower efficiency is fine. You need it cheap, medium to high load, then you go with lead screw. Okay, duty cycle, you cannot keep using this 24 hours a day, 7 days a week. Maksudnya gini, misalnya kamu menggerakkan mesin ya, go forward, and then there is some resting, and then go backward, there is some resting. If the operating or loaded time versus is the same amount of time as resting time, that means 50%, right? But 100% duty cycle means like it's moving all the time. That's 100% duty cycle. So it can be self-lubricating. Okay, when do you use ball screws? You want it when you want high efficiency. Budget is not a problem. Okay, it can be 5 to 10 times typical lead screws. You want higher load capacity, 100% duty cycle, then you do ball screws. Okay. Yep. So when you want smooth motion, efficiency, accuracy, precision, high speed, that's ball screw. Lead screw is cheap, right? Accurate. Some, it's a decent amount of accuracy, but not as critical. Then you do lead screws.
Tapi kalau bukannya ball screw bisa ada backlash ya Pak, kalau nggak salah.
Enggak, kalau ada preloadnya dia nggak backlash. Preloaded ball screws are not, they don't have backlash. Lead screw, kalau kamu nggak mau backlash, you need to use an anti-backlash nut. Ya, itu ada springnya. Create some preload. Kalau ball screw, preloadednya di ballnya. Jadi waktu assembly-nya mereka udah preload it for you. So we'll talk about this next time. Not that many, but I think we're running out of time. So let's stop there. Next week, let's do a Socrative on fasteners and lead screws. Yep, let's do that. Finish the calculation. And we'll use the rest of the time. I want to talk about some linear motion and maybe some useful stuff about motor sizing. Yeah, just automation mechanism stuff will become useful. And then we'll make one extra session for the project advising. Yeah, so next week we'll have 2 sessions. One for the project, you can review some of your design with me, and then one session, the typical class session. Yep. Any questions?